As the carbon-carbon double bond in an alkene has restricted rotation and is unable to rotate, atoms or groups bonded to it are fixed in their positions. For example, if two atoms were bonded to an atom that is single bonded to another atom, those two atoms can swap places with each other in space as the other single bond is rotated. If the same two atoms were bonded to a carbon that is double bonded to another carbon, however, these two atoms are no longer able to swap places with each other as the carbon-carbon double bond is unable to rotate. The only way these two atoms could swap positions in space is if the whole molecule is rotated and turned upside down. The problem with this is that the atoms or groups bonded to the other carbon from the carbon double bond will also have to get flipped. If this other carbon from the double bond is bonded to two groups that are the same, this flipping upside down doesn't matter at all, as even when flipped, the same groups are occupying the same positions as before. However, if the other carbon is bonded to two different atoms or groups, as the molecule gets flipped upside down, the arrangement of these two groups in space changes. This means that the four atoms or groups bonded to a double bond are fixed into place relative to each other. No problem if they are all the same, but if they are different, there are two different ways these groups can be arranged, given two isomers. These are stereoisomers as they have the same structural formula, but in space the atoms are arranged differently. For example, in 1-bromo-2-chloroethene, carbon 1 has a bromine group bonded to it and carbon 2 has a chlorine bonded to it. There are two possible ways that the bromine and chlorine could be arranged around the double bond, relative to each other. This gives two isomers.